So we're doing some vocabulary with statistics. And I don't know what you remember about statistics from previous math classes, but like mean, median, and mode, that's statistics. Okay? Finding standard deviation, finding a box plot. Those are things that you have done probably with statistics before. And you may have heard some of these words before, but it's just some other information to make sure that you're aware of. So the first two words to look at is population and sample. Okay? The population is a collection of all the data. The important thing here is all the data. It's responses, measurements, or counts that you want information about. Sample is a subset of population. Okay, so let me give you an example. Let's say that we want to find out something about students at South Caldwell. And what we decide is we're just going to ask the student drivers some kind of question to find out how students at South Caldwell believe about something. The population is the students at South Caldwell because that's the whole group of people. And the sample would be the student drivers because that's part of the population. Another example would be, let's say that I wanted to find out about the juniors in North Carolina. And what I do is I ask some students at South about the juniors at South and how they feel about testing. The population is the juniors in North Carolina. The sample would be the juniors at South Caldwell. So the population is like the whole group that you're interested in. The sample is just part of that group. Okay? So here's some other examples for us to look at. So number one says, is it a population or sample? An agency wants to know the opinion of North Carolina residents on the construction of a new road. The agency surveys 800 residents. So the 800 residents, is that the whole group or part of the group? It's part of the group. So this is a sample. Because we only interview some of the people. We don't interview every single North Carolina resident. Okay, next. A marketing agency wants to know the opinion of Americans ages 18 to 40 on a new commercial. They preview the commercial to 500 Americans aged 18 to 40. So this 500 Americans, is that all Americans or is that just some? It's just some of them, so this is a sample. Most of the time, when you look at the information, you're going to have lots of samples because it's going to be hard for you to interview or talk to every single thing or person that the question's asking about. Okay, next it says the mean income of all subscribers to a particular magazine is $26,000. We draw a random sample of 100 subscribers and find their mean income is $27,300. Identify the population and the sample. Okay, so the population is the entirety of the group. So what would the population be represented by? All subscribers. Most of the time with the population, it's all of whoever it is that you're looking at. Your sample is the group of people that you take your survey or question or whatever from. And so your 100 subscribers would be the sample. This next one's interesting. Students in the statistics class weighed 30 bags of regular size M&Ms and found that the average weight of the 30 bags, excluding the wrapper, was 1.75 ounces. The Mars Company gives the net weight as 1.69 ounces. Identify the population and the sample. This one's different because it's not talking about people. It's talking about the weight. And this is not one that I would have normally come up with for you to look at, but 1.75 ounces for the weight. This one has to do with the sample weight because that is the weight that they came up with in the class. And the 1.69 ounces is the population weight. because that's the weight that the company came up with, measuring for the entire group. So this is a different one. Hopefully you won't have to deal with one like that very often. Number 5. The following are the entire class's scores on a test. So there's a whole group of scores there. Is this a population or a sample? Anybody want to guess? It seems like it's a population because it's the entire class. I will tell you that it's actually kind of hard to figure it out depending on how the sample or how the test is used. If there's another class that uses the same test and we want to compare all of those tests, this possibly could be a sample of just one teacher's scores, okay? It seems like it's the population because it talks about the entire class, but it is possible that if there's more information, it could be a sample. So I just wanted to point that one out to you. Okay? So that's the first two words, population and sample. All right, the next thing is to talk about types of samples. So whenever you want to determine like information about a group of people or a group of things, there's different ways that you figure it out, okay? If you want to call somebody up, you know those telemarketers that call us, and they say, I've got a quick survey for you. That is called a self-selected sample. And the reason it's self-selected is because you can choose to answer the questions that the person talks to you on the phone about or not. Sometimes there's ads, like on your fast food restaurants, and they ask you to you get a free biscuit if you do the survey or whatever. That's still self-selected because you can choose whether to do the survey or not. Okay? So that's that type of sample, self-selected. You choose whether to do it or not. You volunteer to do it. Systematic is like there's a specific way that we're going to choose people to do the survey. A lot of times it'll say, I'm going to select every 5th person that walks through the door. Or I'm going to look at my list of students and I'm going to choose every 10th person. Or I'm going to choose every other person. There's a specific way that we choose who it is that's going to do the survey. That's systematic. Okay? This one is a really good way to make an unbiased sample. This is pretty biased because only people that are volunteering to do it, that makes the sample kind of not necessarily a true random sample. Okay? Stratified. A stratified sample says that you divide a population into groups and then you survey certain people from each group. So, maybe I divide, as far as the people itself, maybe I divide them into people who play sports and people who don't play sports. And I choose a few people from people that play sports, and I choose a few people from people that don't play sports, and I survey that group of people. That would be stratified, where it's split into groups, and you take a few people from each group. Okay? Cluster is similar to stratified in that you split them into groups. The difference is that you don't take some from each group, you survey one whole group. So if I split apart, don't play in sports, and play sports, I decide, okay, I'm going to survey all the play in sports people because they're the ones that matter about whatever the question's about. If I survey all the play in sports people, that's a cluster because I've surveyed a whole group of my people that I've separated. Okay? There's one more that's not listed here that should be, and it's called convenience. And it's only members of a population who are easy to reach are selected. that would mean if we have a question that we want to find out and we go ask all of our family, that would be convenience, because our family are people that we know and we can call and reach out to easily. If we go and ask our neighbors, that would be convenience, because that's people we know and we can ask and reach out to easily. If we're on a certain team and we ask all the people on our team, that is also convenience, because it's people we know and we can ask easily. Alright, a restaurant owner wants to know whether the customers are satisfied with service. Every 5th customer who enters the restaurant is surveyed. That part right there is the important part, every 5th. That has to be systematic. Because systematic is the one where I choose a certain number and I'll just say every whatever of that person. So that's systematic. Number 2. An electronic manufacturer wants to know the customer's response toward a newly released media player. Emails are sent to customers who recently purchased this device to participate in an online survey at their convenience. Now, the word convenience might throw you off. This is not convenience sampling, because we're not just asking our friends or the group that we know. The important part is that we're sending emails to customers and we're asking them to participate. Because you're asking somebody to participate and it makes them decide whether they do or not, that is called self-selected. Because they choose whether to do it or not. If it's a survey where somebody chooses to do it or not and they don't have to, that's self-selected. Alright, next. A survey is conducted in a state to find out how many households own more than one vehicle. Households are divided into north, east, south, and west. Okay, we're dividing them into 4 categories. Right there, the fact that we're dividing into 4 categories, that tells me it's either stratified or clustered. Okay? A sample is randomly surveyed from each region. So you divided them into groups, and you survey each region apart from each region. That means it's stratified. Because you didn't survey a whole group, you only surveyed a part, but you surveyed a part of every little group that was separated. Alright, questions? Alright. Okay, so number 4 is talking about a manager who's trying to figure out if people are satisfied with the lounge room, and he surveys the employees who are in the lounge room during lunch break. This is convenience, because it's just convenient for him to ask the people who are on break and the people who are just in the lounge room. So it's not, the only reason that it would be self-selected is if the people choose whether to participate or not. And here, there's no choice. He just surveys all the people during lunch break, and that's convenient. All right. The next one says a news station asks its viewers to participate in an online poll about the presidential candidates. So this is kind of like watching a TV broadcast, and they say, okay, if you want to participate, call in this number. That's self-selected because you can choose whether to do it or not. The next one, a sports writer wants to determine whether baseball coaches think wooden bats should be mandatory in collegiate baseball. The sports writer mails surveys to all collegiate coaches and uses the surveys that are returned. Again, you can choose whether to do it or not because it's something you got in the mail. So this one is also self-selected. Alright, next. Here's the easiest one to figure out. Every 3rd person right there tells you the answer. That's very systematic because there's a specific way that we're going to figure out who to ask. I like systematic. It's really easy to figure out usually. Alright, number 8. An amphitheater wants to know if Saturday morning concerts would be attended. The amphitheater is divided into 30 different seating areas. It surveys all the members in 5 randomly selected areas. Okay, that's a cluster because it's separated into 30 areas, and we survey all the people in certain clusters. If we only surveyed a little bit out of each cluster, that would be stratified. That's the difference of them. Number 9. The manager of an orange juice plant wants to test the quality of the plant's new extra pulp orange juice. She does a taste test of every 20th container. Every 20th. Right there is systematic. I think number 10 is the hardest to think about. We want to survey people to find out about waterfront property. And we surveyed 34 owners of waterfront property. They didn't give a lot of information here, but I do think this one is cluster. Sort of what's happened is we've separated the town into non-waterfront property and waterfront property, and we only interview the waterfront property people, and so that would be cluster. And then the last one, a local radio station is considering switching from country music to classical randomly throughout the day, and it announces the phone number and website where listeners can go to place their vote. That is self-selected because you can choose whether to do it or not. So after we take a sample, there are things that you can do with the sample to determine how it's going or determine some information. There's 4 different types of things that you can do. You can do an experiment, you can do an observational study, you can do a survey, or you can do a simulation. Okay? So an experiment, you kind of know what an experiment is from science, where you're just kind of testing what would happen. Normally what happens with an experiment is that the groups are split into 2, and you might not know what group you're in, and they do the same thing to everybody, and they see how it affects everybody. For example, they might give you a placebo, which is a medicine that is just like a sugar pill, and then they give everybody else the real pill, and they check and see how the pills affect each other, but you don't know which one you are. So if it's an experiment on people or even animals or whatever, you don't know what group you're in except the person doing the experiment. So they participate with you, and they give you a control and a treatment group, and they check and see how it's affecting everybody. They said here it was such as methanol to gasoline and checking on fuel efficiency. So there's all kinds of things you can do with an experiment. An observational study is where somebody observes individuals or things. Observing might be looking at a list and comparing. You use it when you can't really control the group, where you can't split the group in 2. And usually they know what you're studying or how it's split up. Survey is where somebody's asked questions and you answer the questions. Okay? Survey is the more common one. And then a simulation is a model where you do a process and you model it with the process to represent some real-world situation. Okay? So let's look at some examples of these. So first of all, number 12, it's written up way up here. A meteorologist uses a computer model to track the trajectory of a hurricane. Because it's a model used by a computer, this is a simulation. We're not asking people questions. We're not just observing what's going to happen. We're not doing an experiment. We're just modeling it. And when you model it, you're doing a simulation. You test a treatment for a disease. If you're testing a treatment, that's doing some kind of experiment. I think I'm spelling it wrong. There you go. You ask opinions on a presidential election. The fact that you ask is the important part there. So that's got to be a survey. Number 15, you compare the grades on a final math test of 25 students who use calculators and 25 who do not. The students decide which group they're in. First of all, you didn't ask anybody anything. You You didn't run a simulation or some kind of model. You didn't do an experiment. All you're doing is comparing. This is called observation. So 16 says, determine if a people who take vitamin C every day are less likely to get colds. I would think this was an experiment that you could do. Some people could take the vitamin C and some people could take a non-vitamin C, and then you could check and see what happens. 17, you determine which brands of orange juice people prefer. You ask each person who walks into the grocery store. The fact that you're going to ask means that you're doing a survey. You test a vaccine for cats. Well, the only way to test it is to do some type of experiment. You've got to check and see if it works or doesn't work with certain cats. So this is experiment again. I think I spelled that wrong again. There we go. Students are selected to see if they agree with the new lunch rules. Well, the fact that you're selecting students and you're trying to figure out if they agree, it sounds like you're going to have to ask them, do you agree? So this is a survey. Next, it wants us to compare grade point averages. Anytime you're comparing, that's observational. Because you're not asking, you're just looking at the information or looking at the data that's given to you. And then the last one says, roll a coin 100 times, let the heads represent having a girl and tails represent having a boy. That is because the percentages, you can represent it that way. But this is called a simulation because you're doing something to represent a certain thing happening. It's kind of like a model of what could happen. All right, when you take a sample from a population and you test something to see how it's going, there's always a margin of error. Okay? If I say that 60% of you like the hybrid method of going to school, and I got that from some kind of survey, there's always a margin of error, meaning it might be a little bit more than 60%, it might be a little bit less than 60%, but 60% might not be the exact amount. Okay? Well, the margin of error, you want the margin of error to be small, so that your percentage that you come up with is more correct. Okay. The important thing right here to know is that if you want the margin of error to be small, you have to increase the sample size. The more people you survey, the more likely that your percentages will come out correct. If you only survey a few people, you haven't surveyed enough people to totally determine if everything is correct. So you always need to increase the sample size if you want the margin of error to be small. This is a formula for margin of error when you're talking about a large population. So number 1 and number 2, we're going to use this formula to figure out our answer. Number 3 is different because on number 3 they tell me that we're looking at a small sample and it gives us the margin of error. So if it gives you the margin of error, you use the margin of error that it gives you. Otherwise, you use that other formula, 1 over square root of n. Okay? So number 1, by the way, n represents the sample size. N represents the number of people that were surveyed. Okay? So in number 1, if I want to find the margin of error, I'm going to do 1 over square root of how many people were surveyed, which is 1,600. You just put that in Desmos, 1 over square root of 1,600, and you get 0.025. That's a pretty small number, so that's pretty good, I think. That means we're only off by 0.025, and that's nice. And number 2, a survey reported that 47% of the voters surveyed, 235 voters, said they voted for candidate A, and the remainder said they voted for candidate B. So how many people surveyed? Or how many people was in the sample? $235. Okay? So we're going to do 1 over square root of 235. and that's 0.065. Alright, the last one. So we're going to use this other formula. N is still the number of people surveyed. So looking at this problem, 50 people are surveyed. So I know there's going to be a 2, there's going to be something on top, and then square root of 50. Alright, S represents the standard deviation. And in the problem it tells me standard deviation is 0.56. So it will give you the information, you just have to plug it in. So 0.56 goes right here on top. You just put that in Desmos just like that, and you get 0.158. And you want the numbers that you get to be small numbers because they're represented by margin of error.